Throughout history, people have created explanations for disease. Many diseases have been seen as being spiritual in origin, a punishment for a person's sins, or as the capricious behavior of gods or spirits. From ancient times, the most commonly held biological theory was that illness was attributable to some sort of imbalance of body humors, hypothetical fluids that were described by their effects, but not identified chemically. Hence, for thousands of years the treatment of disease consisted of appealing to supernatural powers through offerings, sacrifice, and prayer, or of trying to adjust the body humors by inducing vomiting, bleeding, or purging. However, the introduction of germ theory in the 19th century radically changed the explanation of what causes diseases, as well as the nature of their treatment. As early as the 16th century, there was speculation that diseases had natural causes and that the agents of disease were external to the body, and therefore that medical science should consist of identifying those agents and finding chemicals to counteract them. But no one suspected that some of the disease-causing agents might be invisible organisms, since such organisms had not yet been discovered, or even imagined. The improvement of microscope lenses and design in the 17th century led to discovery of a vast new world of microscopically small plants and animals, among them bacteria and yeasts. The discovery of those microorganisms, however, did not suggest what effects they might have on humans and other organisms. The name most closely associated with the germ theory of disease is that of Louis Pasteur, a French chemist. The connection between microorganisms and disease is not immediately apparent, especially since, as we know now, most microorganisms do not cause disease and many are beneficial to us. Pasteur came to the discovery of the role of microorganisms through his studies of what causes milk and wine to spoil. He proved that spoilage and fermentation occur when microorganisms enter them from the air, multiplying rapidly and producing waste products. He showed that food would not spoil if microorganisms were kept out of it or if they were destroyed by heat. Turning to the study of animal diseases to find practical cures, Pasteur again showed that microorganisms were involved. In the process, he found that infection by disease organisms, germs, caused the body to build up an immunity against subsequent infection by the same organisms, and that it was possible to produce vaccines that would induce the body to build immunity to a disease without actually causing the disease itself. Pasteur did not actually demonstrate rigorously that a particular disease was caused by a particular, identifiable germ. That work was soon accomplished, however, by other scientists. The consequences of the acceptance of the germ theory of disease were enormous for both science and society. Biologists turned to the identification and investigation of microorganisms, discovering thousands of different bacteria and viruses and gaining a deeper understanding of the interactions between organisms. The practical result was a gradual change in human health practices, the safe handling of food and water, pasteurization of milk, and the use of sanitation measures, quarantine, immunization, and antiseptic surgical procedures, as well as the virtual elimination of some diseases. Today, the modern technology of high-power imaging and biotechnology make it possible to investigate how microorganisms cause disease, how the immune system combats them, and even how they can be manipulated genetically.